You've seen the scary headline. AI data centers are drinking the world dry, guzzling billions of gallons of water while your town faces a drought. It's alarming, it's everywhere, and like most viral numbers, it's partly true, partly misleading, and a lot more interesting once you look closely. So how much water do data centers really use, and is it a genuine crisis, or a scary number ripped out of context? By the end, you'll be able to cut through the outrage, see where the real problem actually is, and answer the bigger question, why do we even need these things? This matters because the outrage is shaping real decisions, where data centers get built, whether communities fight them, how politicians talk about AI. If the number is misunderstood, we'll aim our worry at the wrong target and miss the problem that actually deserves it. And it sits on top of something unavoidable. The digital world you depend on has to physically live somewhere, and that somewhere uses resources. Pretending we can have endless cloud and AI with no footprint is a fantasy. The real question is how big the footprint is and where it lands. First, how does a building full of computers use water at all? Two ways. The obvious one is cooling. All those chips throw off enormous heat, and one common cheap way to carry it away is to evaporate water, like how sweating cools you down. That evaporated water is gone into the air. The second way is hidden, the power itself. Many power plants use huge amounts of water to make electricity, so even a data center that sips water directly can be indirectly responsible for a lot more, upstream at the plant feeding it. You have to count both, to be honest. So yes, the water use is real, and for a big data center, it can be genuinely large, especially the thirsty evaporative kind. Nobody serious denies that. The trick, and where the headlines go sideways, is what you compare that number to. Because here's the context that almost never makes the headline. Farming, agriculture, uses roughly 70% of all the fresh water humanity withdraws. 70%. Growing food, watering crops, and livestock dwarfs everything else we do with water combined. Against that, all the world's data centers together are a rounding error, a small fraction of a single percent of global water use. Industry, power, even the water lost to leaky pipes in many cities, all dwarf them. On a global scale, data centers are simply not where the water goes. For a sense of scale that stings, the water used to keep lawns and golf courses green in dry regions can rival or beat what local data centers use. We rarely rage about the golf course. The point isn't that data center water is fine, it's that our outrage is weirdly selective. So, if it's tiny globally, why isn't this a non-story? Because water isn't global, it's ferociously local. A drop in the ocean of world usage can still be a disaster if it lands in exactly the wrong place, and that is precisely what's happening. The real issue is concentration. Drop a massive, thirsty data center into a small desert county that's already short on water, and it doesn't matter that globally data centers are a rounding error. Locally, it can strain the same supply the town and the farms depend on. That's a genuine fight. And here's the maddening twist. Companies often build in exactly those hot, dry places on purpose. Land is cheap, power can be cheap, and taxes are low. But hot and dry is the worst possible place to rely on evaporating water for cooling. It's a collision waiting to happen. So the honest version of the headline isn't, data centers are draining the planet. It's a specific data center, built in a specific water-stressed town, is competing with locals for a scarce local resource. Less viral, far more accurate, and it points at a problem we can actually fix. Because this is fixable, and the fixes are already spreading. The biggest one, stop evaporating drinking water. Newer data centers use closed-loop systems that recycle the same water around and around, or cool with air, so they sip a fraction of what the old thirsty designs did. Another fix, don't use clean drinking water at all. Use recycled wastewater or salty water unfit for drinking for cooling. If a data center must use water, using water nobody else wanted is a very different thing from drinking the town's supply. And the simplest fix of all, build them in the right places. Cool climates, near abundant water or renewable power, where cooling is easy and cheap. Where a data center sits matters as much as how it's built. Good siting quietly solves most of the fight before it starts. Now step back, Because there's a question hiding under all of this: do we even need this much computing? And the uncomfortable answer is yes, far more than most people realize. Data centers aren't a luxury bolted onto modern life, they are modern life's foundation. Every message you send, every map you follow, every payment, every stream, every backup of your photos, it all lives in a data center somewhere. Turn them off and the modern world doesn't slow down, it stops. This is the invisible infrastructure holding up everything digital. And now AI is pouring gasoline on that demand. Training and running these models takes staggering amounts of computing, which means more data centers, more power, more cooling, fast. That surge is exactly what turned a quiet infrastructure story into a front-page fight over resources. The useful way to see data centers is like the electrical grid or the water system itself, infrastructure. We don't ask whether we need the power grid, we argue about how to build it cleanly and fairly. Data centers have quietly joined that same category, whether we've noticed or not. Which leads to the biggest question of all. And it's not really about water. It's about power, the geopolitical kind. Because computing has quietly become a strategic national resource, like oil or steel. And there is a fierce, quiet race to control it. So, what happens if China wins? Here's the logic. Whoever has the most computing power can train the most advanced AI, run the biggest science, and build the strongest digital economy and military edge. Compute is becoming the raw material of national strength, and raw materials are worth racing for. So the United States and China are pouring vast resources into building data centers, securing energy, and controlling the supply of the advanced chips inside them. The US has even restricted selling its best AI chips to China, a modern export war fought in silicon. So what if China wins, builds more compute, powers it faster, and edges ahead in AI? It would shift the balance of economic and military power for a generation and put the tools shaping the future disproportionately in one government's hands. That's the stake under the water headlines. But even here, keep your head. Winning. Compute isn't a single finish line. Both sides have real weaknesses, and raw data center count isn't destiny. Power grids, chips, talent, and energy all matter. It's a race worth taking seriously, not a doomsday clock worth panicking over. So let's tie the threads together, because they're really one story. Data centers use real water, but globally it's tiny next to farming. The genuine harm is local, and largely fixable with smarter cooling and siting. Meanwhile, the deeper contest isn't about water at all. It's about who controls compute. The grown-up position holds two ideas at once. Yes, hold companies accountable for draining stressed local water, that's fair and it works. And no, don't let a scary out-of-context number scare us away from infrastructure the whole modern world and our own national future now depends on. So what should you actually watch? First, a metric called water usage effectiveness. Basically, how much water a data center burns per unit of computing. Lower is better, and the good operators publish it. If a company won't tell you their number, that silence is your answer. Second, always ask where, not just how much. A data center on a rainy coast with recycled water is a non-story. The same one in a drought-stricken desert is a real problem. Location is almost everything. Judge them one place at a time, not with one global panic. And third, watch the compute race itself. Chips, power, and who's building capacity fastest. That contest will shape the next few decades more than almost anything else in tech, and it's happening mostly out of sight, in warehouses and power deals you never hear about. So here's the one thing to carry away. Data centers aren't drinking the world dry, but a few of them, in the wrong places, are drinking their neighbors dry, and that's worth fixing. The real story isn't the water. It's that computing has quietly become something nations will fight over. If this cleared the fog a little, subscribe. Clarity is the whole point here. And that race for compute? It's not just superpowers. Next time, how smaller nations, El Salvador turning volcanoes into computing power, Colombia and Brazil, are fighting to own a piece of the future. See you there.